Welcome to this explainer. Today, we're unpacking the B4XDaisyDualRange Library. Now, if you're a developer, you already know the absolute headache of building custom UI inputs from scratch. You know the drill, right? You spend hours writing out custom drawing routines just to get a basic, simple slider working. Well, I was recently digging through this specific component, and I have to tell you, it's a game changer. It radically streamlines how we handle range-based data in our apps. It literally eliminates all those hours of tedious boilerplate code and replaces them with a highly customizable, professional-grade selection tool right out of the box.
Let's dive into exactly what you'll be building. We aren't just talking about abstract code or simple, clunky demos here. We're talking about highly interactive, real-world applications. Think about the friction in a standard shopping app when a user has to physically tap and type into two separate text boxes just to set a budget range. It completely breaks their flow. This component turns that clunky interaction into a sleek, single-track visual experience. Whether you need that budget range selector complete with minimum distances so users can't accidentally select a $0 price gap, or maybe a precise temperature control for a smart home dashboard, this tool handles the whole shebang gracefully. It seriously saves you so much UI headache.
So here's our roadmap for the breakdown today. We're going to start by meeting the component itself, then explore styling and variants, dive into tooltips and feedback, secure our data with validation and errors, and finally, tie it all together with B4X page events.
All right, Section 1. Meet B4XD Dual Range. Let's look at what makes this dual range slider tick and why it's such a massive upgrade over your standard inputs.
The absolutely crucial point to understand here is that this isn't your standard native Android slider. Not at all. It is a highly specialized, dual-handled tool designed explicitly for selecting a specific span of data within a boundary. If you've ever tried to hack together two standard native sliders side by side, or force users to use complex drop-down menus for start and end value, well, you know the user experience usually ends up feeling really disjointed. By giving your users a single intuitive visual track with independent lower and upper thumb handles, you completely remove that cognitive load. They see exactly what they're selecting in one contained space. To make this all work, the component relies on a few fundamental designer properties. Think of these as the underlying physics engine for your slider. You set the absolute boundaries with min value and max value, and you tell the thumbs where to initially spawn with lower value and upper value. Simple enough, right? But the real magic happens with step value and min distance. Think about the frustration of trying to select exactly $50 on a tiny mobile screen with a smooth slider. Your thumb always slips to 49 or 51, doesn't it? By utilizing step value, you can force the slider to snap to clean, defined increments. Pair that with min distance, which guarantees a strict, uncrossable gap between the two handles, and your inputs become completely foolproof. Moving right along to Section 2, UI styling and variants. Let's see how to customize the aesthetic to perfectly match your brand without writing any complex layout code.
The flexibility here is just massive. You've got these built-in semantic color variants like primary, success, warning, and error that allow you to instantly theme the slider to match the context of the user's action with just a single property change. And the sizing system? It's perfectly scaled. By simply changing a drop-down property in your designer from extra small all the way up to extra large, the entire component scales proportionally. The track thickness, the thumb radius, the touch targets, the spacing, it all adjusts automatically. No more manually redrawing bitmaps or calculating layout values across different screen densities. But hey, what if those built-in semantic presets don't perfectly match your app's brand colors? No problem at all. You are not fighting the library here. You have incredibly granular control over the track color, the progress color, which is that filled active space between the handles, and the thumb color. You can explicitly define custom hex codes for all of them. You can even toggle show fill off entirely if your design calls for a super minimalist look where only the floating handles are visible on a subtle track. It's actually fascinating how simple properties can transform a generic slider into a highly professional, context-aware input just by adding a $sign to the value prefix property, or maybe an abbreviation like PX for pixels to the value suffix. The live readout instantly makes sense. There's zero ambiguity about what unit they're adjusting. You can even take this a step further. You can bind SVG icons to the left and right sides of the track to visually reinforce the action. Imagine a small sun icon on the left and a large sun icon on the right for a smart lighting app. It just clicks.
All right, Section 3, tooltips and visual feedback. Because great visuals absolutely need great user feedback, so nobody feels lost while making adjustments.
You actually have two brilliant modes for tooltips built right into the library. And honestly, choosing between them is a great UX exercise. If you set tooltip open to false, you get transient tooltips. These dynamically fade in right above the thumbs only when the user is actively dragging them, and then they smoothly fade out. Perfect for mobile apps where screen real estate is super tight. But if you're building something like a tablet-based audio equalizer or a data analytics dashboard where the user needs to constantly reference exact data points without touching the screen, just set tooltip open to true. That keeps those tooltips permanently pinned and visible.
You can further dial in this feedback to build a complete control panel feel. You can position those tooltips on the top, bottom, left, or right of the thumbs. But beyond just tooltips, you can enable Label Above to inject a clean, structured title, use hint text for detailed instructions directly underneath the component, and activate Show Value for a beautifully right-aligned live readout of the current span. By layering these specific configurations together, you're building a robust input mechanism where the user never, ever has to guess what parameters they're setting. Now, letting a user set data is completely useless if that data is incorrect and breaks your backend, right? That brings us to Section 4, Validation and Error States. I literally love it when a component does the heavy lifting for you. When your app is ready to submit a form, you just call the slider's internal validate method. It systematically checks a few crucial logical steps all on its own. First, it verifies if the component is marked as required. Then it physically checks that the upper value is strictly greater than the lower value. If it's invalid, it automatically triggers a programmatic error state. The whole component visually shifts to an error color and displays your custom error text right beneath it. It completely saves you from writing all that boilerplate logic. But robust validation isn't just about showing errors after the fact. It's about actively preventing them in the first place. This is where the internal mathematical clamp values logic comes in. It acts like an invisible guardrail. Any developer who has tried to manually write collision logic so two UI thumbs don't awkwardly pass through each other knows exactly how much of a nightmare that is to code. If you set a min distance of 10, the clamp value subroutine actively runs during the drag event and physically prevents the user from moving the left handle within 10 units of the right handle. It strictly enforces these bounds for you in real time. It's awesome. Finally, Section 5, Handling B4X page events. Let's dive into the source code and look at how we actually get the validated data out of this beautiful front end and into your app's ecosystem. The public API you're going to interface with in your B4X page source code is incredibly straightforward. During your B4X page created event, you can use the setValues method to programmatically define where both handles should sit. This instantly triggers a visual refresh. When you actually need to pull the data, the getValues method is your best friend, returning a clean integer array containing the lower and upper bounds. But the real star of the show here is the changed event callback, which routes all that live user interaction directly into your backend logic. And here is a perfect scenario of that event callback in action. Inside your DRLive changed subroutine, the component is continuously passing you the exact lower value and upper value as simple integers while the user drags. By grabbing these direct integer outputs, you can trigger incredibly powerful real-time app behaviors. Just imagine taking those exact values and instantly firing a live SQLite database query, which then instantly filters a custom list view displaying product search results on the very same page. You're updating the global state in absolute real time without the user ever pressing a search button. It is incredibly responsive. So, as we wrap up this explainer, I really want to leave you with this thought. How much time are you currently wasting building redundant data validation, custom styling, and frustrating collision logic for your app's inputs? With tools like the B4XDaisyDualRange component handling all that heavy lifting for you, how much more time could you spend actually refining your app's core features? It's definitely something to think about. Thanks for joining me on this deep dive, and happy coding!